Motors. Today we're going to be talking about motors. In air conditioning and refrigeration, motors are playing a crucial part of a system. Pretty much everywhere you go, there is going to be a different motor in the system, either a single phase or a three-phase motor. Now, what is single phase motor? Single phase motor is the motor that is only have two set of winding inside it. One winding called the start winding and the other winding called run winding. On the inside of the motor is going to be a set of coil on one side as a start and the other side as a run. Pretty much something like this is in here and another one right over here. A start winding, it's going to have a lot more turn of wires inside the motor than run winding. A lot of low torque motors, like induced draft motors or like a fan motors, little bitty fan motors on the coolers or freezers, they do not have a capacitor. The motors then they do not require torque, a lot of torque or a lot of power during the runtime. They do not require a capacitor. They can run easily with no capacitor. Now the motors that they're gonna need more torque during the runtime, they're gonna have to have a capacitor. What the capacitor it does, well, I don't want to really enter in too much detail in it, but it's gonna create a third false phase for the system, and it's gonna make the motor run like a three phase. But well, we're not gonna talk about that whole lot. Just remember, a single phase motor gonna have two set of winding inside it, and when you check with the ohm meter, when the system is shut off, you're gonna disconnect the motor leads to check it. You're gonna put your ohm meter on the ohm reading, and then this area then you're gonna check. This is one set, then you're gonna have to check right here. You should get one ohm reading. So then you check over here, you should get another ohm reading. And then the last, you're gonna check right here, and you're gonna have another ohm reading. So you should be able to read three different ohm readings when you check in a motor. A single phase or three phase, doesn't matter, but you should be getting three different numbers. Now, three phase motors. What is three phase motor? Three phase motor, it comes in two different ways. Single phase motors, they're great motors. They use in residential cases, and they don't have that much torque on these motors. They could be torquey, but they're not as much as you need in the commercial cases. In the commercial system or commercial buildings, they have three phase to the building, and they're going to use that, of course. Three phase motor going to have three set of winding in it. As you can see in the delta configuration, we have this set, and this is where the power is going to these three legs. And in the star configuration, the power enters to these three terminals. Three phase motors, they have a lot of torque. They can easily start, they can easily maintain their torque and RPM even under heavy loads. That's why in the commercial systems or industrial systems, you're going to see they always using three phase motors. In the smaller area, like we say, if you're working on the refrigeration system and you have a freezer on the outside, everything is three phase. And when you come inside on the evaporator, you're going to see there's a small single phase motors because they don't need that much power to run those motors. Now we have a capacitor in here drawn on this motor. Some of the motors, single phase motors, three phase never going to have a capacitor. Single phase is the one that sometimes it has capacitor. The motors then they have capacitor designed to be installed on it, that those are the motors that require to have a lot more torque during the runtime. Like in residential cases, you can see every compressor they're going to have a capacitor, or even some of the fan motors on the outside unit on the condenser, they have a capacitor on it. That capacitor is just going to make this motor to have more torque and be able to operate under heavy load. The capacitor on the single phase motor always going to go between a start and run terminals. I'm not talking about the capacitor, I'm not talking about the contactor. A start and run of the motor. Capacitors, if you get those big capacitor with two dual run capacitor, they're going to have a common terminal on it. That's different. So you got to remember, when we're talking about run on a start, it's on the motor itself. Now, what is VFD? What is ECM? You probably hear these here and there. We're going to talk about VFD. ECM is pretty much the same thing. It just has a different terminology. But they doing the exact same thing. ECM used in single phase, VFD used in three-phase systems. What ECM does, it takes the 240 volt power that it goes in, or 120, it doesn't matter what the input is. Depending on the design, get the input, single phase input, and it's gonna put out a three-phase output. And that motors that they use in ECM to be operating, they have a, let me show it to you. This is a regular single phase motor, then we're gonna be taking it apart later on in the video. The ECM motors, you're gonna see there is a thick aluminum part on the back of the motor. And when you turn the motor, you can feel it clicks every time that you turn it, because internally they build different. For the single phase cases, that's pretty much that's what the ECM is on the back of the motor. ECM turn the single phase to three phase by modulating the amount of voltage and the frequency. It can slow or speed up the motor. VFD doing the exact same thing. Variable frequency drive. It is changing the voltage and the frequency, so these motors can run slower or faster, depend on what you need. You don't want the motor to run at 100% all the time. Sometimes you want to slow it down because you have multi-stage systems. So then these parts are coming in use, and they make the unit a lot more efficient by dropping the speed of the motor down to use it as it designed. Here we go. We have a motor, then we're going to take it apart. But before I do that, I want to show it to you what happened when the power goes through a set of a coil that is wrapped around an iron core. This is pretty much was something like this, and I took it out of my screwdriver. And then I wrapped a set of wire around it. Now this wire that I wrapped it around is not a bare wire. This wire has a paint as a insulation around this wire. I just burned these ends of this wire a little bit so that the insulation it goes away, and we can test it out. If this was a bare wire, when you try to make a magnet out of it, it's going to short out immediately. But before you understand how the motor works, I'm going to show you how this works, and this is pretty much explains how the motor works, how these relays are working with a sort of coil inside it and everything. You see right now, this is not magnetic. It's not going to pick up this metal. But as soon as I supply power to this, then it's going to become a magnet. So this principle is used in those relays and in the motors. The only difference in the motor is this is constantly changing. There is multiple set of this setup is inside, and multiple times this is changing, and that change is gonna cause this shaft to rotate. Now I already took the screws out of this motor so we can take it apart and we can take a look at it. Every one of these motors are made out of these components. There is a set of coils, a lot of windings are in here that is wrapped around these iron cores. There's a stator that is turning in the middle of the motor, and the end housing. Sometimes you see some of these motors when you buy it, they have a little plug at the end. So you have to pay attention when you install in the motor to remove the plug that is need to be removed. If the motor is mounted this way and the shaft coming out from this side and the blades are on this side, you need to remove the plug from this end. But if the motor is installed this way and the shaft is on the top, you need to remove that plug from the bottom. That plug is pretty much in case of any water went inside the motor, any condensation build up inside the motor, to be able to drain out. That was just a tip. Now, how to check the motor? As you can see inside the motor, there's 3 set of wire comes to these terminals. 1, 2, 3, 4 is marked, but number 4 is blank. There is nothing in it. So we have 1, 2, 3, and 3 wires are hooked up to it. The motor has the schematic on the side of it, that where the power and the capacitor need to be hooked up to this motor for this motor to function. And of course, on the motor, it does say what size capacitor you should be using. 15 or 10. This motor can run with either or, depend on the frequency. If you are using it in USA, which is 60 hertz, you have to install the 10. But if you're using it outside of the US, which is 50 hertz, you have to use a 15. Now, how to check these motors? You pretty much, all you need is an ohm meter on the ohm reading, and you need to check these terminals. You should be getting reading on all 3 to each other. So first, you're gonna do the first one with the middle one. It shows 55 ohm. Then the first one with the last one, it shows 64 ohm. Then second one with the last one. As long as you get the low ohm reading, you see, you want to be ohm reading, not the kilo ohm, not the mega ohm. You see right now it says M, then ohm symbol. That's mega ohm. It's very high ohm reading. Like you say, if I check my body across my body, it reads around 170, 180 kilo ohm. You don't want to be in the kilo ohm reading. You don't want to be in the mega ohm reading. It should be in the ohm reading only. You see, it's only an ohm. Every 1,000 ohm is going to be 1 kilo ohm, and every 1,000 kilo ohm going to be 1 mega ohm. Mega ohm is very high resistance. Kilo ohm is moderate resistance, which is your body. And then ohm is a low resistance. Keep that in mind. So if you check the 2 legs and you see it's showing to you kilo ohm reading or mega ohm reading, that's a bad motor. So that's how you can check. Now, since this was a single phase motor, all these 3 legs to each other, they have a different ohm reading. A low ohm reading, but a different ohm reading. A 3-phase motor, when you check these 3 to each other, they're going to be exactly the same. They're reading exactly the same reading. It's just going to be 3 terminals. Now, these motors, they build to go in 1 rotation only. As you can see, this one, the rotation is counterclockwise. Only rotate in this direction. On the 3-phase motors, they are usually designed to go in 1 direction, like we say if it's a scroll compressor or is a rotary compressor. But the motor itself, it can go in either direction. All you have to do when you have 3 legs of power going into the motor, all you have to do, pick 2 phase, doesn't matter which you're picking, but 2 of them, and you just swap them out. And when you do that, the motor, instead of going this direction, now is going in this direction. On reciprocating compressors, of course, it doesn't matter which direction the motor is turning. On the 3-phase system, it's going to be right rotation anyway. But on any other type of compressor, you want to make sure that you're turning in the right direction. One other thing that you want to always keep in mind when you check in motors. After you check the winding and you see if the motor is not running, you want to make sure that the bearings are good. We say if you go and you turn the motor and you start hearing this noise, it's bad. If you move this and you see a little bit of play in this shaft, just a hair, then you can feel it. That means that's bad. That means the bearing is internally is destroyed, is no good anymore. So always when you turn these motors, when you're checking this motor, first thing you check if the motor is shut down. Is make sure that actually the bearing is good. This motor doesn't want to go back together, so I can show it to you. But when you turn the good motor, it's never gonna make any noise at all. It's just gonna be as smooth as it could be, just like this one. You can hear nothing. The motor is nice and smooth. There's no noise, no nothing. But the steps to check: first thing, you want to make sure the motor is not hot. So you touch it really quick, see if it's hot or not. After you shut the power down to the system, you shut the power down first. You check the motor, see if it's hot or not. If it's hot, there is a thermal overload. It's right here. It's wrapped around this plastic that you cannot see, but there's a switch. It's a thermal disk switch inside that if this winding gets too hot, it's going to disconnect these legs from the windings. It's going to disconnect the wires. So if you check a motor that is hot, these terminals to each other is not going to show you any ohm reading. The motor might be good. You maybe had a power problem and it caused the motor to go on the overload. That's what is called overload. But that's what it is. If the motor is hot, you have to wait for the motor to cool down first. Of course, that's the first thing you want to check, see if the motor rotating easily. If this shaft is rotating pretty easy and doesn't have a problem. If it is, you have to cool the motor down with water, or you have to wait for the motor to cool down and then test it again. You might have a bad relay. You might have a bad power going to the system that it caused the motor to overheat. But that's how you can check the motors. There's nothing really hard about it. The more practice you do, the easier it gets for you. My suggestion is anytime you come across a bad motor, then you change it out. Don't be afraid. Take it apart. Take it apart like this. Take a look inside, see what happened to that motor. Why that motor went bad? Was it one of the bearings was bad? Was it one of the windings? You can see a burn mark on it. What happened to the motor? That's how you can practice and you can get better at it. This is it for today. If you have any question or comments, put it down below.